Hey everybody, welcome to our notes on Chapter 1, Target 3C, where we'll be solving literal equations and formulas. So, here's the deal. A literal equation is an equation where, oops, sorry, let me get my pen going up here, where the variables represent known values. All right, and so this is what we mean here is we won't have an equation with an x or a q or an r or whatever else, and it's just a random variable. The variables are going to vary specific links to things in real life, such as height, length, distance, time, even slope. Slope variable of m is a variable that represents a known value. Another word, a lot of times, you'll hear literal equations referred to as formulas. All right. Formulas like back in geometry when you had formulas to find the area, surface area, the volume, all that good stuff. And you can almost always guarantee that we will have multiple variables in the literal equations. I don't know of a literal equation that only has one variable. I'm not 100% sure, but I don't think it's even possible to have just one single variable. So it'll be multiple variables, two or more variables here. The good news is we're going to use all the same steps and techniques that we did back when we had a single variable in our equation and kind of go through the same process. The only difference is now when we're adding, subtracting, multiplying, dividing, doing our steps, we're going to have to learn how to work with a value that's staying a variable instead of a value that's a known number. All right, so let's take a look at some examples here. Let's look at 1 and 2. So in number 1, we have E equals mc squared, which is Einstein's famous equation to quantify energy there. E is energy, m is mass constant, or the mass, and c is the constant for the speed of light, which honestly, off the top of my head, I don't know. But the bottom line, all we need to be able to do is to get c alone. We're solving for c. We want to isolate the variable c. All right, so the first thing we should do is we need to get rid of any other variables that are not c. Anything else that's not c, we need to get it over to the other side there. So we've got an m. It's m times c squared. So what we're going to do is I'm going to divide both sides by m to cancel out the m. Right? So now what I have is e over m, and that is equal to c squared. So now what we've got to do is we got to get rid of that exponent of 2, that power of 2. Well, we should know that the way we cancel out a power is with our radicals. The way we cancel out a square is with a square root. So then what I'm going to do is I'm going to take the square root of each side. The square root, the root of 2, will cancel out the power of 2. And what I will be left with is the square root of e over m is equal to c. And you can see now what I've done here is I have solved that equation for c. All right, let's check out one that has a fraction in it. Let's look at number 2 here. So in number 2, we have to get d alone. So you can see there's no other variables on the same side as d, but we've got to get rid of some coefficients, some constants, and that denominator there. The easiest way to get rid of a denominator, which is division, is to multiply. We multiply by 3 on each side, and that cancels out the denominator, so I have 3c equal to 2d plus 1. Now, we have to get rid of the constant 1 and the coefficient 2. And if we remember, we get rid of the constant before we get rid of the coefficient. So I'm going to get rid of the positive 1 by subtracting 1 on each side. Since 3c and 1 are not like terms, I have to leave them as separate terms. And now, to finish this off here in red, we want to get rid of our coefficient. We get rid of 2 times d by dividing by 2. And you can either divide each term individually by 2, or you can write 3c minus 1, both terms together, over 2 there. I don't like the way I wrote my d, so I'm going to erase it, and I'm going to make it a little neater. There we go. All right, and so that right there is that equation solved for d. So as we scroll down here, we have a couple more. So what I want you to do right now is I want you to pause the video and try these on your own here, and then we'll come back and you can turn the video on and I'll go through the steps here quickly on how to do those. So ready, pause. All right, so let's take a look and see how you did. So if we want to get v alone here, first thing we would do is add gt squared to both sides. So I'm going to end up with h plus gt squared equal to vt. Then I want to get rid of the t, so I'm going to divide by t. T cancels. I'm going to divide by t here, divide by t here. I did it separately because one of the t's up top will cancel with the t on the bottom. I'll end up with h over t plus g over, g over nothing. That's what I got, just g, because the t canceled out, equal to v. And that's what you would have there. So hopefully you got that. If not, please come to class and ask some questions. We can talk about that. All right, now solve for L. It's kind of hard to tell, but that right there in the middle is the L. First I'm going to do is get rid of the term that does not have L in it. So then I have E minus U equals 1/2 LW squared. Then I want to get rid of my coefficient there, the 1/2. I can do that by multiplying by 2. And if I multiply by 2, I got to make sure I multiply that whole side by 2. So now I have 2 times E minus U equal to LW squared. All right. Then I can divide by W squared to get rid of that. And we have 2 times the quantity E minus U. And that's Miss Safari in the background. Hi, Miss Safari. You want to say hi?
Hi.
Hi, she said hi. Equals W squared equals L. All right, so we've done a number together here. So what I want you to do is do 5 and 6 on your own, come to class, and we'll talk about the correct answers for 5 and 6 in class. If you got nothing done for 5 and 6, then I know you really didn't watch the notes or you didn't try hard. So please give it some effort, and we'll see you in class.